Bismillahirrahmanirrahim. So once again, I would like to continue my lecture from another problem of the higher order differential equation. So this is the second problem. In this problem, we have d2y minus 9y is equal to 2 exponential 3x plus 5 exponential x. This is the problem, and now we are going to find the solution of this problem. So first of all, we can say this is equation number one. So first we will find the complementary function for this differential equation, as I told you earlier in my previous lecture. So how we will proceed the solution. For the complementary function, we will consider the left hand side of the differential equation, that is d2y minus 9y is equal to 0, so that this can be written as d2 minus 9 into y is equal to 0, and the characteristic equation of this equation can be written as r square minus 9 is equal to 0. From this equation, by using the formula difference of 2 square a square minus b square, so we will get two values of r from here, that's r1 and r2, which will be the r1 is equal to plus 3 and r2 is equal to minus 3. It is no matter if you are taking first r minus r3 and second r plus r3. If you can take anyone earlier and later, no problem. Now we have r1 is equal to 3 and r2 is equal to minus 3. Now the um, complementary solution becomes yc is equal to c1 exponential 3x plus c2 exponential minus 3x, because we know that when we have distinct root, y is equal to c1 exponential r1x plus c2 r2 exponential s. So that uh, after the complementary solution, now we will proceed further for finding the particular integral, that is yp. So for the particular integral from equation number 1, this is equation number 1. From here, equating, we will equate the value of y from here, that will provide us particular integral of the differential equation. So look at this here. We equate y from equation number 1, that is y is equal to 2 exponential 3x plus 5 exponential x divided by d square minus 9. Now we have two terms at the right hand side, so by breaking LCM, we can write the denominator with both the terms, so that we can write it as 2 exponential 3x divided by d square minus 9 plus 5 exponential x divided by d square minus 9. Now at the first part, we can the directly apply the integral formula with the exponent. That is, we know that this formula, a exponential bx f of d, can be written as a exponential b f exponential bx divided by f of b when we have f of b not equal to 0. So here, when we substitute b is equal to 3 in the equation, so this equation becomes 0, so that we cannot proceed this formula directly, apply this formula directly on this part, because of the value of b is 3. When we substitute 3 here, the square of 3 will be 9, 9 minus 9 will be 0. Therefore, we apply here other rule. What is the other rule? Other rule is that we must be differentiate the denominator. After that, we apply and multiply the whole factor, entire factor, by x, so that what we have to do, this factor 2 exponential 3x, it will be written as, and we multiply by x and divide, and denominator will be differentiated with respect to d. So the derivative of d square minus 2 will be 2d minus 0, plus this factor here, the value of b is 1, so that we can apply directly this rule here, a exponential bx f of d is equal to a exponential bx f of b. The value of b is 1, so that square of 1 would be 1. So we can apply here this formula on directly. So can be written as 5 exponential x upon 1 square minus 9. So the first term becomes 2x exponential 3x. Now after the differentiation, we will apply the same rule. This f of d will be transformed into f of b. So the value of b is now here 3 here, and the second term 1 minus 9, that would be 1 minus 9, that would be it. So there is a little mistake. It is plus sign. plus sign. Uh, 5 exponential x upon 1 minus 9. So little simplification, this 2 will be cancelled out. These 2 will be cancelled out. And remaining term will be x exponential 3x upon 3 plus 1 minus 1 minus 9. 1 minus 9, that is minus term, minus 8. So that would be minus 5 upon 8 exponential x. So the general solution of the differential equation we can write as y is equal to yc plus yp. So yc is c1 exponential 3x, c2 exponential minus 3x plus 1 upon 3 x exponential 3x, and this will be the minus sign. So this is the solution of uh, this differential equation. Now we will solve another problem for more clarification. So we have chosen another problem, that is d square minus 2d minus 3 into y is equal to 3 exponential x minus 2 sine x. This problem consists of two functions at right hand side, but these two functions are not the simulated function. The first function is exponential function, another is circular function or trigonometric function. So what we have to do first, we will proceed the solution for the value of complementary function. Now directly I will write the characteristic equation from here, because I have already explained you how to obtain the auxiliary equation, then characteristic equation from the given differential equation. So now I will directly start my solution from the characteristic equation, that is r square minus 2r minus 3 is equal to 0. By the factorization, factor becomes r square minus 3r plus r minus 3 is equal to 0. So that we will get the factor r minus 3 r plus 1 is equal to 0, that is r1 is equal to 3 and r2 is equal to minus 1. So our complementary function becomes yc is equal to c1 exponential 3x plus c2 exponential minus x. Now I will going to find the particular integral. For the particular integral, we will take the equate the value of y from the equation number 1, that is what, y is equal to y is equal to 3 exponential x minus 2 sine x divided by d square minus 2d minus 3. Now here again we have two functions at the numerator, so we will break the LCM here again. By breaking LCM, it can be written as 3 exponential x divided by d square minus 2d minus 3 minus 2x sin x divided by d square minus 2x minus 3. Now we have two different kind of functions here at the numerator, so we will apply here two different kind of rules. One is one is uh, rule to find the particular integral for exponential function, another to pursue the solution for trigonometric functions. So uh, look look at the rules here. First I will tell you regarding the rules, what are the rules here. So first rule, which we already know about, the rule is a exponential bx upon f of d can be transformed into a exponential bx divided by f of b when f of b not equal to 0. We have to remember this, right? If f of b is equal to 0, what we have to do? We will multiply numerator by x and differentiate the denominator with respect to d, then substitute b here. So this process will continue until we obtain f of b not equal to 0, right? So, and the second formula here, a exponential bx upon f of d square becomes a si- a sine a sine bx divided by f of minus b square. Here we will replace minus b square. So remember here, the square is only on the b, not on the minus sign. So this negative sign is separate from the b square. Also, another formula is there when we have only c with f of d, which can be written as imaginary part of exponential iota, because you know that the complex number exponential iota theta is equal to cos theta plus iota sin theta. So we can write it as imaginary part of exponential iota bx upon f of iota b. So there are two formulae we can be applicable in case we have circular function or trigonometric function in our problem. So in the first part, that will be written as 3 exponential 3 exponential x b b square minus 2b minus 3, and minus 2 sin x divided by 1 square minus 2 minus 2d minus 3. So here value of b is what? Value of b is 1 here. So we will substitute b, for instance, d. So uh, here we have, in our question, we have d square minus 2d minus 3. So here we will substitute the value of b, that is 1. So 1 square minus 2 into 1 minus 3, and in the second in the second part we have angle, coefficient of x in the angle of sine, that is b. So here value is 1, so we substitute here b is equal to 1 also. Now further solution or simplification, this can be written as 1 minus 2 minus 3, that is minus 5, minus 5 plus 1 will be minus 4. And similarly here, uh, because we are substituting minus 1 square, for instance d square, so we have d square only first term. So uh, at the at, at the place of d square we will replace minus b square. So this will be the separate negative sign, and b is 1, 1 square minus 2, d will remain as it is, minus 3. So first part will be 3 exponential x upon minus 4 minus 2 sin x divided by 2d minus 4. After that, here we do not have, because we do not have d square here, so we cannot apply this formula further to find the solution. Therefore, first part, it is our answer of the first part, but in the second one, what we have to do, because we have the linearity, so we will apply this rule. Second rule, we have sine here in the second function. So sine is the imaginary part of the complex number. So here we will write here 2 is the coefficient, 2 times of imaginary part of exponential iota x divided by 2 f of b. B is iota. So 2 iota plus 4. This part will remain as it is, plus imaginary part of this 2 will be cancel out by taking 2 common from these two terms. We will take common 2 from these two terms, will be cancel out from the from the 2 which is given in the numerator. Now the remaining term will be imaginary part of exponential iota x upon iota plus 2, because we cannot leave the solution when we have complex number in the denominator. So in that case we must uh, little bit solve this to get the imaginary part from this portion. So first term will remain same, and in the second term we are going to find the imaginary part of this entire term, so that we must multiply and divide by iota minus 2, uh, so that in the denominator we will get the difference of 2 square, that would be a square minus b square. After the application of basic formula a square minus b square, this iota plus 2 iota minus 2 will be converted into iota square minus 4. And you know that iota square is a complex number, and we know very well what is the value of iota square. Iota square is minus 1. So for iota square here, we will write minus 1, minus 1, and minus 4. Uh, this term, which is in multiplication, iota minus 2 will multiply by exponential iota x. So in the denominator, we have minus 1, minus 4, minus 5. And when iota x will multiply by I and 2, that will be I exponential iota x minus 2 exponential iota x. And look, first term is as it is, minus 1 upon 5 imaginary part of iota cos. What is this value? This value we obtain from where? From exponential iota x, right? This is the value of exponential iota x. So here, substitution of the value of exponential iota x, also minus 2. Substitute the value of exponential iota x, which is cos x plus iota sin x. So after multiplication, both the terms with iota cos x will multiply by cos, and with iota x, and you know that iota into iota will be iota square. Iota square is minus 1. Plus minus 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 2. It is just simple simplification. 2 times of cos x minus 2 times of iota sin x. So here we have 4 terms in the bracket, 2 with iota and 2 without iota. These 2 without iota are the real part. We will separate them, and rest of 2 from which we can take common iota, and the remaining terms are cos x minus 2 sin x. So this is the imaginary part of the term. So what we are going to take from here, we will only going to take the imaginary part from this. So imaginary part is this part. This part is the imaginary part. The coefficient of iota is the imaginary part. So our solution will be minus 3 upon 4 exponential x minus 1 upon 5 cos x minus 2 sin x. So now our final solution for the entire differential equation can be written as y is equal to yc plus yp, that is complementary function plus particular integral. So y is equal to c1 exponential 3x plus c2 exponential minus x minus 3 upon 4 exponential x minus 1 upon 5 cos x minus sin x. Now another problem, because we have various kind of cases in the differential equation, so we must be clear. We must, for the clear understanding, deals with the different kind of problems, so that we can understand in different cases when we have some kind of exponential function, trigonometric function, polynomial, or addition of the function, multiplication of the function. So uh, in different cases, how we can deal with the solution of the higher order differential equation. So for more clarification, I am taking here a third order differential equation, that is d3y upon dx cube minus 2 d2y upon dx square minus 5 dy upon dx plus 6y is equal to x square minus 2x. So uh, as usual, first we will find the complementary function, that is yc. So uh, d cube minus 2d square minus 5d plus 6y is equal to x square minus 2x. So the auxiliary equation of this differential equation becomes m cube minus 2m square minus 5m plus 6 is equal to. There is no matter when you are taking um, an arbitrary function of your choice. So I am taking now here m. No matter you are taking r or m, but you know that you are just only going to find the roots of the equation, so that you can take the any of the variable as you choose. For example, you can write here a cube minus 2a square minus 5m 5a plus 6. It is up to you. Now this is the third order differential equation. We must find the three root from this equation. So for obtaining the root in the easiest way, we are applying synthetic division method to find the first root, and we can see that here 6, 1, 7, minus 2, minus 5, 7. So if we will substitute 1 in the equation, left hand side, right hand side, then both will be equal. So therefore, I will start my division from 1. So first, taking the coefficient 1, minus 2, minus 5 and 6 from the equation. 1, minus 2, minus 5, 6. Now what is the process? First term will remain same. Now this first term will multiply by 1, 1 into 1, that will be 1, and this one will be add in the coefficient. So minus 2 plus 1, minus 2 plus 1 is will be minus 1. This minus 1 will multiply by 1, that would be minus 1. So we will write here minus 1, minus 1, minus 5, minus 6 multiply 1, that will be minus 6. So we will write here minus 6 plus 6, that would be 0. Remainder is 0. So our first root m1 will be 1, and the remaining remainder is m square minus m minus 6, that is m square minus m minus 6 is equal to 0. Now it is a quadratic equation. We can easily find the root of quadratic equation by using the different methods. So here I am taking the factor. So the factor of this second order equation will be m in m square minus 3m plus 2m minus 6, m minus 3 plus 2, m minus 3 is equal to 0. So our factor are m plus 2 and m minus 3. So the value of m2 and m3 are minus 2 and plus 3. These are all three roots, and see that all the roots are real and distinct. So you know that in case of real and distinct root, the solution will be what? Solution will be y is equal to c1 exponential m1x plus c2 exponential m2x plus c3 m3x. So the value of m1 is 1. Therefore, yc becomes complementary function will be c1 exponential x plus c2 exponential m2, that is minus 2x plus c3 exponential 3x. So for particular integral now, from equation number 1, we will equate the value of y, that would be yp. So y is equal to x square minus 2x divided by d3 minus 2d square minus 5d plus 6. I need your concentration here. If you will emphasize a little bit here, this problem is little bit lengthy because we have second order polynomial, but we have third order polynomial, second order function in the denominator, that is consists of d, third order, and polynomial is second order, that is x square minus 2x. So according to the rule, we will shift the denominator into the numerator. So the power of the entire factor will be negative. So d cube minus 2d square minus 5d plus 6 minus 1. Now taking common 6 from the entire term. So when I will take common 6 here, that will be 1. So I will write first 1 here minus, there is no presence of c, so c will be in the denominator, and also here that will be 2 upon 6, that would be 1 upon 3. So here uh, because we are taking common 6, so or 6, so there will be 3. Little bit mistake, so you must be corrected. Here coefficient is 1, so no presence of 6, so 6 will be written in the denominator, and multiply the polynomial, that is x square minus 2x, and the whole power is, this factor is minus 1, right? So after taking common, we can write it as in form of a plus or minus b. So our a is 1 here, and rest of all term is my negative term is b. So do it correct. This is not 6, this is 3. So now uh, it will be 6 into 1 minus, in the second bracket, 5 upon 6 d plus 1 upon 3 d square minus 1 upon 6 d cube whole power minus 1 into x square minus 2x. And here, if you will see uh, in the equation, first term and second term. This is the first term, this is the second term, and we know the very common property of the binomial expansion is, we know that when we have, because 1 minus x raised to the power minus 1 will be equal to what? 1 plus x square plus x cube and so on. So when we will apply the same rule on this equation here, that will be 1 minus whole power minus 1. So it will be 1 plus x square and so on. So just I will take up to the x square. Why I will take the term up to x square? Because our higher higher power of the polynomial we have is 2. Therefore, we will only take the polynomial up to order 2 in the in the bracket, and we will terminate, and we will not write, because you know that d is the differential, and the differential of x square is 2x, and when we differentiate 2x second time, that will be 2, and third time d third order derivative will be 0. Therefore, we will take only all the terms containing the power 2 for for the differential. So in the bracket here, there are little bit mistake for the coefficient. So no matter coefficient does not matter. You must be understand the solution. And we will, when you will understand the solution, you will be able to solve the problem by yourself. So I am doing correct myself, but if I forget to change the value or a little bit a multiplication mistake, so please do ignore. I will be thankful to you. So here, first term will remain same, and second term here is 1 2 3. There are three terms in the bracket. So uh, in case of linear power, just we will open the bracket, so this will remain same. But here we have three terms in the bracket, and and over power is 2. So we'll apply this formula, a plus b plus c whole square, which you have studied in the metric class. This a will be equal to a square plus b square plus c square plus 2ab plus 2bc plus 2ca. According to this formula, we will apply on the third term. So first term will remain same, second term will remain same, and here this is 1 upon 3 d square minus 1 upon 6 d cube plus, when you will open by a square, this will be 25 upon 36 d square, b square, it is not 36, 9, because we have 3 in the denominator, b square d 4 upon 9, and third term d 3 square is d power 6 upon 36, and a b b c c a, when you will multiply all the terms we will get the higher power. So we will not write the all the terms, we will terminate the series up to the power 2 of d only will take, because I already written here, because you know that d expressing the differential, that is d is equal to d upon dx. So in above equation we have second degree polynomial, therefore we only takes the differential of the maximum order 2, right? So here in the equation, the differential with maximum order 2 are 1 upon 6, 1 plus 5 upon 6 d plus 3 31 upon 36 d square. There is little bit mistake of the coefficient, so do calculate again what would be the value of this uh, uh, this fact, this coefficient. I don't know, might be because I have written there uh, wrong value, so do it yourself. And the polynomial is x square minus 2. When you will multiply this x square minus 2 with the all terms, 1 5 upon 6d, 31 upon 36d square. So we will get x square minus 2x plus 5 upon 6 differential of x square minus 2x, 31 upon 36 d2 d2 of x square minus 2x. It means that we will differentiate this polynomial two times. Now 1 upon 6 x square minus 2x plus 5 upon 6, and differential of x square minus 2x will be 2x minus 2. And here 31 upon 36, uh, d will remain same, and first differential will be 2x minus 2. So we will differentiate this term again. That will be derivative of 2x minus 2 will be only 2, and derivative of 2 will be 0. So we will write it as x square minus 2x plus 5 upon 3d 3x minus 5 upon 6 plus 31 upon 18. And after simplification, finally we'll get 1 upon 6 x square minus 1 upon 3x minus 8 upon 9. So now we can write the entire solution of the entire differential equation. That would be y is equal to cf plus pi, that is yc plus yp, and yc is c1 exponential x plus c2 exponential minus 2x plus c3 exponential 3x plus 1 upon 6 x square minus 1 upon 3x minus 8 upon 9. So I will stop here my solution. In the next lecture, I will continue from another problem to show you how to obtain the solution of more differential equation when we have more cases in the higher order differential equation. So I would like to uh, request you do appreciate me by like and subscribe my channel and my videos. I would be thankful to you. Thank you so much.